So, okay. So, this is our topic about torsion. Okay. So, first, i-discuss muna natin yung about torsion on shaft. So, we all know now what is the difference between torsion and bending moment. Okay. So, alam na natin na yung torsion is that type of moment that acts relative to the cross-sectional area. Okay? In contrast with the bending moment na ganito yung direction. Okay? So, first of all, nilagay ko muna yung mga formulas. Actually, alam ko naman na for you students, mas madali if i-memorize nyo muna yung formula. Okay? So, generally speaking, ito yung mga formulas ng torsion on circular shafts. Okay. So, let us consider this cross-sectional area. Okay. So, parang, let us say na parang nag-cut ka mula sa shaft mo. Okay. And from that shaft, meron kang radius rho from the center. Okay. So, this rho doesn't necessarily point out to the area, okay, to the outermost part of your shaft. So maybe your rho is somewhere here. Okay, so pwede si R mo is from center to the outermost side. But sa mo si rho, pwedeng nasa gitna siya. Okay? So, pwedeng bumuo ka ng imaginary circle dyan. And then si rho is hanggang dyan lang. Okay? So, in order to find the torsion, okay, so, of that, of this, from, to that, rho distance from the center of the cross-sectional area of the circular shaft. So we have this relationship. We have gamma is equal to the first derivative of theta or the angle. So this is your theta actually. Oh. So meron kang angle na theta dyan. Okay, yan. We have the angle theta. So, first derivative of theta with respect to x times the rho. Okay? Into which, any distance from the circle, okay, to a point inside that shaft. Okay? It is not necessarily equal to r. Okay? So, therefore, your tau or your shear stress, actually, your tau is the sign of your shear stress. And then your gamma is your shear deformation. Okay? So if you remember, shear strain. Okay? Your gamma is your shear strain. So your shear stress is equal to the modulus of elasticity times the shear strain, which is your gamma. Okay? So you replace that, you will get this relationship. Okay? So some problems will require a differential equations like this. So if the problem calls to use this relationship, pwede natin gamitin to. Okay? So that is it. Okay? So speaking of, yung torsion mo kasi is patagilid siya. So nagkukos siya ng shear stress. Kasi alam naman natin yung shear stress is pakiskis. Kaya ganun, okay? So, pasensya na if nauna kong i-explain tong relationship na to before yung about sa shear stress which is induced by this torsion, which is letter T. Kasi patagilid, no? Naisip nyo ba? Kasi patagilid siya, yung force niya is patagilid din, which is causing shear stress or shear stress. Unlike nung bending moment, pag ganun siya, so nagkukos siya ng normal stress. Okay. So, another relationship, important relationship we need to know. Okay. So, we have theta or the angle of rotation. Okay. So, kasi torque or torsion is caused by torque. Okay. And this torque will result to torsion. Okay. So, this theta is equivalent to the integral of d theta from L, okay, sorry, from 0, this is na theta, 0 to L, okay, into which your d theta is equivalent to T over G times J. So, your G is your modulus of rigidity, okay? So, if you remember the relationship between G and the modulus of elasticity, in which your G, okay, nakalimutan mong ilagay, your G is equivalent to E over 2 times 1 plus the Poisson's ratio. Okay? So, if you remember this class, okay, this relationship, okay? So, your G here is the polar moment of inertia. So, your G here is the polar moment of inertia. In which it is equivalent to the sum of Ix and Iy. Okay? So, naalala nyo yung, so I hope naalala nyo yung nasa statics of rigid bodies natin, no? Natackle natin yung Ix and Iy. Speaking of shear stress, so your shear stress or tau is equivalent to T times rho times J. So, where rho, again, as I explained, is in any distance from the centroid, from the center of your circular shaft to any portion within the circular shaft, the cross-sectional area of the circular shaft. So, itong rho is actually might be less than or equal to the radius. Okay? So, para makuha natin, yung rho is parang imaginary circle siya. So, parang imaginary circle siya within this larger circle. Okay, so yung rho hanggang dito lang. So, habang technically from 0, from the centroid, 0 itong si shear stress. Pero habang lumalayo siya mula sa centroid, lumalaki linearly yung shear stress mo. Which is from 0 to TR times J. Okay? Kasi yung maximum radius mo, maximum distance mo from centroid to the outermost part of your shaft, okay, the cross-section of your shaft to the outermost portion is R. So therefore your rho max, your tau max or the maximum shear stress is equivalent to the torsional force. Okay, so your torsional force is either in kilonewton meter or in kip foot, depending if you are using SI or imperial units. Okay, so remember, this is the formula of your J. Okay, given na yan kapag circular. So, if circular solid shaft, ibig sabihin walang butas sa gitna, is equivalent to pi r to the 4th over 2 or pi d to the 4th over 32, where r is your radius and your d is your diameter. Your hollow shaft is slightly different because your J or your polar moment of inertia is equivalent to pi over 2 times the big R to the 4th minus small r to the 4th is equivalent to pi over 32, okay, times d to the 4th large D. So, yung big D mo is yung bigger diameter mo. Okay? And then, yung small letter D mo is yung smaller diameter mo, which is equivalent to twice the small r mo. Okay? Yung small d. Samantalang yung big D is equivalent to twice the large r mo. Okay? The big r mo. Okay? So, therefore, from this figure, okay, sa sinabi ko na, since rho is any distance from center to to a certain point inside the cross section, yung rho max mo, since yung pinakamalaking possible value of rho mo is equivalent to R, so let us say your rho max is technically equivalent to R. So therefore, your shear stress, maximum shear stress equivalent to the torque times the radius of the shaft over J, where J is the polar moment of inertia. So, when we substitute these values to J, so we get this another formula for the tau max or the shear stress, maximum shear stress, which is equivalent to 2T over pi small r cube, or equivalent to 6T times pi small d cube. For hollow shaft, you substitute this one, so you will get this one. So this is tau max or the maximum shearing stress, okay, is equivalent to 2T big R over pi times big R to the fourth minus small r to the fourth, which is equivalent to 16TR over pi times big D to the fourth minus small d to the fourth. Okay? So after this, in order to better understand our lessons, we will have some examples on different videos. Okay? So I hope you understand the concept. Okay? So we go on through our next video. Okay? So stay tuned.